Right, so here's a short clip on orbital motion, so why things orbit. So what's important to remember is if we had a rocket that launched into space, okay, and we just launched it straight up, okay, and then we turned the rocket engines off, it would just fall back down again, okay. So what we have to do is launch it into orbit. So we might launch it and then we'll send it round like this. And it'll be trying to go out in this direction. So if it's our rocket here, or our satellite, which is here, okay, there's our satellite we draw. And what will happen is Earth's gravity will end up pulling it back in towards the centre, okay, and that has the effect of making it go in a circle. So it wants to carry on moving in this direction, it wants to carry on going straight, but what happens is the Earth's gravity pulls back towards the centre, okay, and pulls it around in a circle. So if that's our satellite again, it wants to go in that direction, okay, but Earth's gravity pulls it back round, okay, and that's essentially an orbit. Because they're in outer space and there's no air resistance, okay, and there's no friction to slow it down, these satellites just move at a constant speed and they just move around the Earth constantly. Okay, so essentially they're just constantly falling back towards the Earth. Okay, but its velocity is stopping it from actually hitting the Earth. It's missing every single time. Okay, now there's an important fact that we need to know. Velocity equals speed in a given direction. So a satellite or anything that is orbiting is changing velocity, not because its speed changes, it's because its direction is constantly changing because it's going in a circle. So satellites like these artificial satellites will orbit and their speed is the same, but their velocity is constantly changing because they're being pulled round in a circle by Earth's gravity. Okay, now moons and planets do the same thing. So moons will orbit planets and their velocity is changing because they're changing direction, but their speed of orbit remains the same. Same for planets that orbit the sun. Now, Earth's gravity is strong close to it and it's weak out here. So that means if you're orbiting close, okay, like you are here, the velocity, the speed at which you need to orbit is high. So high orbital speed. Okay, and then if you have an orbit that's out here, like this one, that's further out, it's weaker, the gravitational force from the Earth, so you have a low orbital speed. So it's the same with the planets. So if the sun's in the middle, you've got Earth here and on there, and you've got Neptune way out here. Okay, Neptune is much further away, so the sun, the gravity from the sun is pulling on it a lot less. Okay, so we've got a smaller arrow there pulling on it a lot less, so it's weaker, so it orbits slowly. If it orbited too quickly, what would happen if it would fly off into space? Here, what we've got is the Earth, and it's much closer to the sun, so that means it has to orbit quicker. Otherwise, if it orbits too slowly, it will fall into the sun. Okay? In the same way, Neptune, if it orbits too quickly, it will fly out into outer space. Okay? So that is the idea of orbital motion. So what is name given to objects that orbit a planet? Okay? They are called satellites. So we can have natural satellites like the moon. So natural, but we can also have man-made like the Hubble telescope. Okay, but they are both called satellites. So we can have natural ones or we can have man-made ones. Now, explain the effect of the Earth's gravitational force on the moon, of the motion, of the Hubble Space Telescope. So what happens is gravity causes the satellite, or the Hubble Space Telescope satellite, to accelerate towards the Earth. That means change direction towards the Earth. Okay, so we spoke about this up here. The satellite wants to go straight. Okay, it's moving in that direction, but Earth's gravity, the gravitational force, is pulling it round into an orbit, into a circle. Okay, and that is what's happening. Gravity causes satellite to accelerate towards the Earth, so it's turning. It was going away from the Earth, it's turning towards it. It just doesn't have quite enough force to turn it back all the way so it falls to Earth because of the velocity of the satellite. Okay, then this changes the direction, so we say this changes the direction of motion. So rather than going into outer space, it heads towards the Earth. Okay, so changes the velocity. So as a result, so changes the velocity of the satellite. Okay, so remember an important fact here. Accelerate simply means change in velocity, and we can change the velocity in two ways. We can either change it by changing the speed or changing the direction. Okay, because remember, velocity is speed in a given direction. So if that's the case, we can get an object to accelerate by changing its speed or direction. In this case, this satellite is accelerating because it is changing direction, and it's changing direction because Earth's gravity is pulling it back round towards the center of the Earth. As I've said before, it doesn't pull it enough to fall back to Earth, it just pulls it round, and as it comes around it just misses, and it continuously misses and misses and misses and misses. So it just ends up going in a circle over and over again, and we call that an orbit.